So my name Henki. We will discuss today a simulation of a seal truss design using Pluto. We have here the truss systems. Yeah? It consists of 21 bars connecting each others in the joint. The joint number is 12. We have here at each end support, the hinge one in node 1 and a roller in node 7. So during the design, we need to analyze the structure and evaluate the internal force at each structural member and its deflection, produced by applied load following the building's code. So several technical decisions should be made for a good practice of design. First one is selecting the economical section. Second one, we evaluate the strength, stiffness, and deflection of the systems. Third one is we must simulate many load cases according to building standard. And we must prevent the excessive deflection because it will impair its function as a structure. So in order to do that, we must solve an equation of equilibrium, and we write the equilibrium equation in terms of unknown joint displacement and stiffness coefficient. Once the joint displacement is known, the internal force of the structure can be calculated using the force displacement relationship. So this is the equation of equilibrium. The stiffness matrix multiplied by the displacement, we will get the forces, or the load. So first of all, we must construct the element global stiffness matrix. We can get it using the element local stiffness matrix multiplied by transformation matrix transpose and multiply by matrix transformation. So for example, we can get the element 7 or element 4, and then we can assemble it into a global stiffness matrix of the structure, and then after we reduce it by 3 degree of freedom with 0 displacement, we get the stiffness matrix. We define the nodal load. Here still 0 because it is not yet applied, or it is already small part is applied. To solve it, we use backslash in Julia or factorization, and we get the displacement in 24 nodes. Node 1, node 2 is 0, and 14 also 0 because of the boundary condition of the support. After we get the displacement, we can have the internal forces using this formula. First, we can have a coordinate system according to the angle of the roof and the length of the truss. We set up also the maximum deflection, delta divided by 250, and we have these drawings. So This is the displacement of each node in x direction and in y direction. We have his internal forces of 21 element, and then also its stresses. So we reduce first the load, yeah, and the section. We use the small one. We set up the height of the truss or the angle, yeah? And then we can also change the length of the truss. The dashed line here is the maximum displacement, can be allowed by the building codes, yeah? And then we can apply the load. Okay. So the maximum displacement is the deformed truss is the green one, and undeformed truss is the purple one. So we can see here the displacement of the truss is 733 millimeters, and it is almost delta max is 91 millimeters. So this design can be approved, but if the load is bigger and bigger, the displacement is getting bigger, and the forces also, and the stress also, it is already exceeding the yield point of the steel. Yield point of the steel for example, 240 Newton per millimeter square. So, but if we increase the section, for example, 0.0027, the stress is lower, the force is bigger, but the displacement is acceptable. So this is very handy for a new student or new engineer for to design and also evaluate the displacement and the stress directly. So this is very very good. Using Pluto is one can study much faster the relation between the load, the stiffness, and the displacement. So thank you very much for your attention. We do hope see you in next time. Thank you very much. Goodbye.
All right. Thank you, Henki, for the about finite methods.
Yeah.
That was a very cool diagram, the bridge. Can you tell us
Yeah.
can you tell us how you draw the bridge interactively?
Yeah. Actually, it is my lecture in steel structure. So the difficulties of the student is they are struggling to calculate the uh, force in each member. It takes sometimes 3 months to calculate it with the hand and so on. But with Pluto and some code that I make, some function, a student can do it in only 2 weeks. And with Pluto, only 2 hours. Student can slide the the slider, and they see the differences, the displacement and the stress, because it is for new student is very difficult. We must run the program many times to get the feeling, that to get the feeling, how the engineering feeling, what is the change of section and so on. So I actually take example in plots, example from your uh, notebook, and to draw it. So each student have a different uh, bridge to 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 solve it, and I just solve for my students. So the code can be applied to any bridge that they supposed to finish it.
Cool.
It's very cool. Any Pluto feature, any new thing in Pluto that would help you?
Yeah, I think I don't know. I'm not the programmer, but if it is possible, we can I don't know, the plot, for example, I can call it directly from the other function, not in the Pluto itself. I don't know. So I just get the coordinate or something. Also, for example, the next step is I want to put some data frame in it, so student can change the type of
The material.
section, and then the area is changed. So but that I think it is very cool. Very cool. I can put it in my university server and so on, so student can directly learn the interaction. Because it is difficult in our today's, so many commercial software to uh, available, but the university is a public university. We cannot use so easily the program and so on, because it takes so much cost. But using some function in Julia and Pluto is very fantastic. So people can see directly the plot and the stiffness changing. And my next project, maybe I will have a dynamic calculation. So for example, the building is shaken by the earthquake, and then I see the displacement, the shear, the moment changing during the earthquake. So we can design the buildings more beautiful, and see directly the effect of this earthquake.
That's
That is
amazing.
amazing.
I'm really happy to hear that you're enjoying Pluto, that you're using it for education, using it for finite differences, and that you're using these sliders also in education. So thank you again for your great talk, for the beautiful notebook.
Thank you.
And
Nice to meet you guys.
nice to meet you. Yeah. So right now we'll take a small lunch break, a very small one, and then after the break we'll be back with the next talk by Clark Evans about the hypertext literal. Thank you, Henki, and thank you.
Thank you.
Thank you, your kids.
Bye.
Perfect.